policy advice and practice, success stories, challenges, impact, and limits. And the first case study that we will be dealing with now is called Food from the Oceans, and you will learn all about it in the next 45 minutes or so. We have two very interesting speakers here on the panel that I'll introduce in a second. They all have the challenging tasks of limiting themselves to 5 to 7 minutes max, which I'm sure they'll manage, in order to have a little bit of time for the discussion as well. We will start with Professor Ole Petersen. Ole is the Vice President of Academia Europaea and also Director of the Academia Europaea Cardiff University Knowledge Hub. He has held many posts in academic societies and funding bodies. For instance, he was Secretary General of the International Union of Physiological Sciences. He is a Professor of Physiology at Cardiff University in Wales. And what I liked, I choose this from your bio, he was appointed in 2008 Commander of the British Empire for Services to Science. I think Ole is a great person to have with us here today. And the title of Ole's talk is How to Get It Right from the Start. Ole, the floor is yours.
Well, thanks very much, Julia, for this introduction. So we are talking here in this session about one particular topic, namely food from the oceans. I'm not a fisheries expert, I should say immediately, so I am not an expert in this area at all. But this question came from Commissioner Vella, Commissioner for Maritime Affairs, and the question was how to potentially extract more food, more biomass from the oceans in a sustainable manner. And I will not talk much about the actual report because, as I say, I'm not an expert, but more about the mechanism by which we reached the production of what we call an evidence review report. This was actually evidence review report number 1 from SAPEA, so it was in that sense a little bit of a pioneering task. It was, I think, to the surprise of many people, actually delivered on time and was actually a very substantial report. It's 160 pages long, and given that this was carried out essentially most of the work in a 6-month period, I think it proved that it is possible for academies actually to be effective, because that had been one of the sort of major doubts, I think, in the minds of many policymakers. Okay, academies may be composed of eminent people, etc., but they take their time and probably they can't deliver on time. So at least the process was efficient. Now, when I had chosen this title, How to Get It Right from the Beginning, it is because I think the experience here showed how crucially important it is for the initial scoping review to be very thorough. And so some of us were a bit concerned that it took a little while before we had totally formulated things and totally decided on all the different elements that had to be conducted. But actually it proved in the long term to be a very, very important step forward. So one of the best, I think, advices initially to get it right is make sure that you know exactly what it is you are talking about and exactly what you're going to do, and also exactly what you're not going to do, so that you have really a confined task that actually is approachable. The next question is, of course, to get the right experts together. In this particular case, SAPEA decided that the lead academy for this was Academia Europaea, and this is how I came into this process of being responsible from SAPEA for guiding this process through. So having decided on what we wanted to do and what we did not want to do, we knew the kind of experts we were looking for. And here it turned out that we had a great convening power. So we issued invitations for nominations, actually were signed by the SAPEA president, Günther Stock. And this made clearly a good impression in the community, because we had a massive number of nominations, no less than 154. And this happened within a few weeks. So lots of people actually from the academies were keen to participate, and they nominated not only members of the academy, because in this particular area there were actually not masses of members in the academy in that area. So many members of the academy knew about other people who actually were real experts in this field. And so the difficulty was then to select. We did that very quickly by a telephone conference call. And out of these 154, we then finally turned it down to less than 20. 2 different working groups were put forward, because in this particular case, it was clear that there was a need for the natural science expertise in the marine biology, obviously, but there was also a need for the social sciences to play an important role, because if you propose changes in the pattern of food consumption and so on, you also have to think about all the economic consequences of this and whether the public will actually want to do that. So these working groups were fairly quickly established, started to work. There was a great coordination between the 2 working group chairs. And most importantly, we had a very effective administration on this, namely in the hands of Louise Edwards, who is the manager of the hub in Cardiff that Julia just mentioned, who drove the process relentlessly and made sure that everybody was on time. And this is an important process. So I won't talk much about the recommendations themselves, because as I say, we are not in a fisheries discussion here, and I think Ian will say probably quite a bit more about that. Now, in addition to getting it right from the beginning, there's another element that I just want to touch on very quickly in these few minutes that I have been allowed to do, and that is outreach. It is a part of the important contract between the European Commission and SAPEA that in addition to producing the evidence review report, we also need to have outreach. We need to tell people in the communities about it. And we have had a lot of these activities in different countries. And they divide basically into 2 different groups. On the one hand, one would like to have a big audience, and we had a major presence at an international food festival, for example, in Cardiff, where very large numbers of people knew a bit about what happened. However, if you had done an examination afterwards of whether these people really had learned a lot, it probably wouldn't be all that much. But they had some awareness was there. In contrast, at the Hamburg Academy, we had a much more confined session where about 100 people came to a quite detailed evening session, and we had scientific presentations, and there was a very good discussion with the public. So this was a smaller number of people, but these people probably had actually learned quite a bit about it. And so we have to be careful again when we evaluate outreach activities, how we deal with this. On the one hand, it looks impressive if you have large numbers, and there's a good point about that. On the other hand, we also have to think about how do we actually evaluate whether these outreach activities are actually effective. And in the UK, where we have a research excellence framework where we evaluate also impact, non-academic impact, we are looking not just at the number of people who are present at a particular event, but also at whether it changed perceptions, changed knowledge about things. And I think that's very important. And finally, I just want to sort of make a more general observation, because we have been talking so much during both yesterday and today about trust in science. And I think there's been one thing that really has been missing. I made a short allusion to that in an intervention yesterday. The most important thing about trust is actually past success. We trust science because it has actually given enormously fantastic results over many, many, many years. And that's the real reason for it. It's not that we are nice, that we can speak in nice language to other people or something like that. The trust is based on actual results, something that works. And I think that's just as well to remember that. And those academies that are respected are those academies that have a long track record of actually electing people who have changed the world and have actually made something happen. And I think it's very important that we keep that perspective in straight. The problem here is, of course, that a timeline can be very long between scientific discoveries and actual results, but ultimately we only respect those who create something that actually works. And I think I am hopefully within my time, and I will stop here.
You are just perfect, Ole. Thanks very much. Okay, Ole, you have reassured us in your talk that academies can indeed be fast, which I think is a wonderful statement in the context of our discussion today. You have also alerted us to the importance of thinking about ways to evaluate the effectiveness of knowledge and to think about impact, but also in different dimensions. You again brought up the notion of interdisciplinarity and that we need the perspectives of all sciences to look at issues, also if you want to have impact. And then you also reassured us or reminded us of the fact that trust is not something that is very short-term, but it's actually something that is earned and that is based on actual results and a very, very long history of doing science. Good. We will take these issues up in the discussion, I'm sure. I would now like to invite Pearl. I don't introduce you again, Pearl. I'll just give the title of your talk. So Pearl will be speaking on food from the ocean scientific opinion, a broad and deep range of potential policy actions. Pearl, please.
As is the case with Ole Petersen, who's not an expert on food from the oceans, I'm not an expert on food from the oceans, although I have become a little bit of an expert, and in fact, enough of an expert to present our work, our recommendations in the European Parliament, and even respond, I think rather adequately, to questions of the parliamentarians, which is interesting because our scientific opinion is for the Commission, but this topic has been picked up by a large number of legislators. What's nice about this session, and I'm sure the session following it at this conference, is that we're not just talking about doing science advice, or talking about it, or actually doing it. So that's what I'm going to be talking about as well. This was the first time that the group of chief scientific advisors worked with SAPEA and were very, very, very happy with the collaboration. I want to say that Carina Casquetalo was the person who was primarily responsible for the work on the food from the ocean. So I'm just a deputy. And I want to acknowledge her wonderful contribution. SAPEA wrote the evidence review. So that is, what does science know? What does science not know? And it was done, as Ola said, in a very short period of time. And I talked to many of the scientists involved in the report, and they were saying, we were under so much pressure, but they did it. And we were surprised and we were very gratified to see their willingness to work with SAPEA, to work with us. And one of the issues that arose is, well, what did they get back? Yes, we're working on, or SAPEA is working on ways to remunerate them, but we can't, they're not getting a publication out of it. They can put on their CV, yes, they contributed to an evidence review, and which served as the basis for scientific opinion. And what we subsequently did is that our chair, Rolf Hoyer, sent a letter to the university or the institute where the scientists were employed, also sent it to the scientists themselves and said, we want to thank you for allowing your scientists, or we want to thank you, individual scientists, for working with us. We can't give much, but it's a way to acknowledge the important contribution that they made. I want to make 3 points that we learned in our work on food from the oceans. And that is that this opinion, and again, we're talking about the evidence review, but then after the evidence review, what was done is we had to make a landscape of the policy. And believe me, there's an awful lot of fisheries and marine ocean policies at all kinds of levels. But we need to know this landscape to know what kind of recommendations might be most effective. So the evidence review was mostly the state of art of the science, but in addition to that, there was a review of the policy landscape where the JRCs, the Joint Research Centers, turned out to be very helpful, and also the policy scientists with whom we were working. But what we found is that concrete and actionable science-based recommendations, and some were very broad. That's the long-term perspective that Franz Blum was referring to. And some were very specific, but that both can be provided in responding to a very general and open question. And Ola told us what that open question was. That is, how to obtain more food from the oceans without compromising their value for future generations. So what were the specific guidelines? Include mariculture, so that's food from the oceans. Don't forget, Europe is a lot about agriculture, and it's a lot about fisheries, but somehow mariculture, so harvesting and culturing food from the oceans, doesn't fit into the picture. But how suggestion would be to give mariculture in what has to happen by 2020 is that each country in the EU has to develop a national marine spatial plan. And these spatial plans, of course, it's a lot of competition about land or about waters very close to land. So here you get the competition between the fisheries, between leisure, between the food culture. But these countries have to develop some kind of a compromise when they're developing their national marine spatial plans. So we gave the recommendation, and of course we'll have to see how easy they are to implement. And then we had broader recommendations, like putting in place a concerted mariculture developing policy framework on integrating fisheries and mariculture and agriculture into a cross-policy food systems approach. And of course, that's much more difficult to implement. And it'll also require some breaking down of very typical silos, the silos between agriculture and fisheries and between food. And so we're saying, but this is a very cross-cutting issue. Policymakers, you might need to step out of your comfort zone or your vested interests and look at food from the oceans as part of a larger food systems framework. And the running debate on the post-2020 policy and budgetary priorities of the EU at the highest level provided a propitious moment for ambitious evidence-based ideas. So the timing of the opinion is essential. That's my first point. The second, and this is a point that's also been alluded to by Peter Halligan and by Siavuya Bulani, is the combination of the natural sciences and the social sciences. And it was crucial, a crucial basis for the recommendations in our opinion. Neither body of evidence on its own was sufficient. The compelling figures on the biological potential for increased food harvesting by themselves would have failed to deliver plausible and actionable recommendations to a situation where the social science literature was unanimous in pointing to governance failures as the single biggest barrier to increases in ocean food harvesting. And this was a point that was also made by Karina Angelieva when she talked about the need to include administration or issues around administration and regulation in providing scientific advice. And the social sciences literature is adamant that regulation questions, whether they're about culture or capture, are key to releasing growth potential. And here it's important to address the complexities of balancing pure economic efficiency considerations with social, cultural, and sustainability concerns. And the social sciences literature also underscores the determinant role of consumer preferences as a market pull enabler in developed and developing economies, educating people for, might be a value-laden term, smart eating, moving away from meat and think of all of the resources are required for the production of 1 kilo of meat protein versus the fewer resources that are required to harvest protein from the oceans. My third and final point concerns the multi-level relevance of the recommendations. As I said, the primary receiver of our opinion was the College of European Commissioners. But as work progressed, and it took us somewhat by surprise, it became clear that the recommendations would implicate policy actors at all levels of governance, down to, yes, local community level, especially those concerning mariculture, given the locus of competences and the way in which subsidiarity applies in this domain. And this has become even more tangible since the opinion was published, with scrutiny and debate of the opinion undertaken by European Parliament, the Committee of the Regions, member states, and indeed many concerned private stakeholders at both European and national levels. You will not believe the number of invitations we receive as chief scientific advisors to speak, for example, in the Basque region or in Cyprus, and so forth, and so forth. This fact, so the multi-level governance fact, puts the closeness of the date for the publication of the post-2020 EU budgetary priority proposals, makes it tantalizingly interesting for us, 5 months after we delivered the opinion, to see where and in what way across the different levels our advice is being acted upon. Maybe one of you or one of the speakers, and I'm turning to Ian, of course, is aware of other such impacts that might have escaped our attention. But one of the things we are doing, and the Secretariat is doing, is seeing where our recommendations are being referred to in the development of specific policy recommendations and legislation. Thank you.
Thanks very much, Provost, for being so focused and for giving us very, very practical things to think about when it comes to providing science advice to policy. You reminded us of the fact that we should not be, in this on all levels, afraid to break down silos, that this is actually a precondition, and that we have to step out of our comfort zone, and this goes for policymakers as well as for scientists. You also spoke of an issue that did not yet come up today, but this is crucial. Basically, the reward systems for scientists, they are not being rewarded for doing science advice, for engaging in activities around science advice to policy. So this is an aspect that one has to think about. How can this be acknowledged? How can they not be punished for spending time on writing this kind of reports and not writing the next scientific paper? It's not a trivial issue. You also said that it's very important to understand the actual landscape where the advice will be operating in, and that there are a lot of different layers to think about and to consider. You reminded us again, and I like this, so I can't hear this often enough, of the importance to integrate the different sciences into the work. And you also spoke about the finding or the insight that you gained, and that you actually discovered that there are a number of different layers of recipients for this advice, and that it's very important to think about them and then to also address them and interact with them. Yes, I think I'll stop here. There are many more, but I don't want to take Ian's time. So Ian is one of the recipients, I would say. So he represents the European Commission. He's working in the Directorate General for Maritime Affairs and Fisheries, where he's a senior expert. Ian is a physics graduate, And Ian has worked for the European Commission since 1980, mainly on scientific support for EU policy. And Ian's current work aims to help the EU realize the potential of the blue economy. And Ian will focus on important issues for bureaucrats.
Yes, thank you for the previous speakers. I think you set the scene very well. I'd like to maybe, this exercise was so successful, I'd like to see how we could even extend it in the future by explaining little bit some practical case studies of how we needed scientific advice and how we got it, and it might surprise you. So I want to talk 3 issues: marine litter, Fukushima, and food from the oceans. So let's start with marine litter. This is a real case study. 1st of December 2017, we were asked to propose a legislative proposal for single-use plastics and fishing gear, so as to reduce the amount of plastics in the ocean. And it had to be ready by the 5th of March 2018. So this is trying to take advantage of the huge public concern about plastics in the ocean and trying to get it, a legislative proposal, into the works before the Parliament changes. So as part of the work, we requested support from Deloitte and signed a contract with them in December, and they helped. So we have to present these proposals to our impact assessment, to what we call a regulatory scrutiny board. And this is a really tough process. You have to really make a case for why you want to make the proposal. So you have 2 months to make this case. And so it's pretty difficult because you look at all the different measures of how much plastic's going in. Scientists all know about uncertainty, but bureaucrats don't really. We like to have one figure, you know. So if you look at different models of microplastic, of what goes into the rivers, they're vastly different. And that's just one publication. Other publications give other numbers. So you can't do a mass balance, but you want to know what's going in, so in order to know what the impact of your measures are. So in the end, we assumed that what goes in from fishing gear is 20% of what's bought annually. So that was our assumption. But how do we choose our framework contractors? Well, most of the contracts in this case for impact assessments go to these framework contractors, who are basically a set of consultancies, to Deloitte, Pricewaterhouse, etc., who are specialized in, very good in writing proposals. And in fact, it's the selection proposal. It's important that you know that the selection is a bit different from research projects. They only have to be good enough. They only have to have 5 years experience in offering advice in the Commission or 5 years knowledge of fisheries issues, and most of them have, so it's quite easy. And the award is only a price and quality. So in fact, we didn't use much of their advice anyway. And so this is how a lot of advice is given to us on matters that are quite scientific. The next question we were asked was on the 11th of March 2011. There was a tsunami which caused massive release of radioactivity into the Pacific. And we were asked, is it safe to import fish from the Pacific? And of course this is quite important and quite urgent, because of course there's a lot of fishing industries in the Pacific whose livelihoods depend on it. And there's huge consumer fear that about this radioactivity, and if you make a mistake, if some radioactive material gets into the food chain, it could ruin the market for fish for a long time. So this was there were a lot of questions we had to answer very, very quickly in a month. What are the concentrations in the water? What are the concentrations in the fish? Sediment. Does radioactivity accumulate or decay in the fish? What are migration movements? And are the isotopes soluble? And how does water in the Pacific circulate? And this is, no one expert can give you all this information. You have to go round everybody and ask and telephone. And of course it's Easter and everybody's on holiday. So this is a typical type issue that we have. And in fact, after a while you start to understand the problem. You understand that the actual radioactivity in fish doesn't accumulate, but it diffuses out, and there's a diffusion coefficient and a half-life dependent on the difference in concentration in the fish and in the water. But you have to it takes a while, and then you're looking at, do tuna move into the contaminated zone and then move out and can be caught elsewhere? It was difficult. So, but I think Nature wrote something about this that was that was exactly my experience. That the Japanese authorities released a lot of data, but it was in PDF files that you had to try to convert back into Excel. But when the Japanese PDF, Excel seems to be different, and a lot of time was wasted in this, and it was difficult to communicate with the Japanese authorities because we had to go through several layers of administration. But if the data were more available in a rapidly consumable format, then it would have been much easier to get this big community, worldwide community, working on the problem, because you've got they'd probably be more agile than us, and we could get them, geeks, hackers, university students. It was an interesting problem, and they could have all helped, but the lack of data wasn't, not the lack of willingness, but the lack of suitable data was a difficulty. Then the food from the ocean, the good example. So this was fantastic. So the question we asked was, why, our commissioner asked, Commissioner Vella, 50% of the primary production in the ocean provides only 2% of human calories. How do we get more out of the oceans? And this was also, apart from the practical question of feeding the expanding populations, it's helping to get scientists out of their mood that the oceans are there as a wilderness. The oceans are also, they're obsessed with acidification, sea level rise, but it's also an opportunity. We want to look at the opportunities there. And I go back, but anyway, the timescale was as Pearl described. It was very fast and very good. I just did a slide, but I don't know how to go back. But the impact, well, it's a bit like what Chou En-lai said about what was the impact of the French Revolution. You know, he said it in 1970 or something. He said it's a bit early to tell. It has actually framed the support for the aquaculture supporting the Commission proposal for the post-2020 EMFF. So it has actually succeeded in that. And it has brought more coherence between Commission departments in food security policy, if this works. So, for instance, this is the Agriculture Commissioner, and when our Commissioner and Commissioner Moidash, who's the Research Commissioner, circulated this advice amongst the Commission College, he replied that it clearly identifies the potential, and the benefits are evident in terms of circularity and reduction of so it's what Pearl was speaking about. It's trying to get us out of our silos, to get the maritime policy, the fisheries policy, more into all the other policies, so that we're acting together. And I think it has succeeded, and it's going to have an even more impact in the future. It was a really interesting piece of work, very high quality, and this is how science policy should work. And so lessons learned, it was a transparent process. The speed is essential, and like for the first one, open data can help. And for our regulatory scrutiny board, they like numbers, but you have to be able to somehow look at how uncertainty comes into it. And I understand you're going to look at this particular issue in specific, and that's scientists understand uncertainty, but us bureaucrats don't. You know, it's a difficult concept for us. Okay, that's it. Thank you.
Thanks very much, Ian, for giving us this very practical perspective, also from your daily work point of view. I think it was very helpful to remind us how advice is being given in practice in the Commission, also how policy decisions are being taken. I found this example of the statistics of untraceable origins interesting. Also the time issue, and we said, well, sometimes we need to get advice very quickly. I mean, to reach someone over Easter, it's simply impossible. So how can we deal with this? And the point that you mentioned again at the very end of your talk, namely the difficulty of communicating and dealing with uncertainty, which of course is a very tricky issue in the context of our discussion today. I would now like to open the discussion immediately and to give you the opportunity to ask questions to our panelists on the study on food from the oceans, but also in general. So really whatever is on your mind. And please raise your hand if you have questions, and then again move to the microphone, present yourself very briefly and ask your question. Okay, Professor Stock, please.
I'm impressed by the openness Ian showed, especially with the plastic in oceans, where you had Deloitte in the game. And you mentioned that you did not use too much of this advice anyhow. I don't ask for the reasons, but I would like to ask my fellow colleagues within SAPEA if we would be asked to make rapid advice in terms of those topics, because Deloitte has to go to our scientists anyhow. They cannot create their own data in this short period of time. Would we have to think about a new financial structure, what is given to SAPEA, because Deloitte got money and they paid money for the people who helped them out? And the question is there a structural need to rethink rapid advice also in terms of money? And therefore I would like to ask the question if there is a quality issue, yes or no, not in detail, but how we would think in SAPEA about carefully looking about the issue of rapid advice, especially when it comes to new contract. I think that is fantastic that you were so open. Thank you.
Yeah. Pearl raised, of course, this issue about rewards, and I think it's a very important one. At the moment, we are in a curious situation where scientists are paid for advice from certain European organizations and not from other ones. If you are an ERC panel member, you are paid. But if you are a member of a SAPEA working group, you're not paid. And okay, there is a nice letter coming from somewhere, but it probably doesn't cut a lot of ice with the vice chancellors of different universities who are basically interested in sort of more concrete measures. So I think with the food from the oceans, we were very lucky. As I said, we had a fantastic response. There was probably kind of enthusiasm for a new process, I suspect. And for that reason, a lot of people were willing to be there. I think in the long term, there is a need actually for doing something, because you cannot have an ecosystem where in some cases substantial amounts of money are paid and in other parts they are not paid. And so I think for the European Commission there has to be some kind of thinking about looking at the overall picture of what scientists are asked to do and what kind of reward they have. And we all appreciate a nice acknowledgement letter, but as I say, at the end of the day, that is not what makes people decide whether to do something or not do something.
This is the rapid. The issue is the rapid response, and yes, you are drawing a parallel with serving on grant panels, but that's when we know in advance which scientists will be doing it. But I'm sure there's a way around it with, I don't know, per diems or some kind of remuneration. Nevertheless, what I experienced is that scientists are willing to contribute because there's a willingness to serve the greater good. So I think people shouldn't be asked to be doing too much in their free time. We all know we scientists do a lot in our own free time. Do we have free time? I don't even know. But I wouldn't want to emphasize the financial too much. I don't want to disregard it either, but what a point I want to make is that there's an enormous reservoir of very sharp minds out there who are willing to help. And don't forget that we as university administrators, and now I'm talking as also a research director, are working towards developing new guidelines, evaluation criteria. And there's this terrible word, it sounds like as if it's English, but it isn't. It's the word valorization. And yes, there's pressure on scientists to valorize their research activities in terms of getting a patent or starting a business. But this is a different form of valorization, and that is, it's sort of like teaching, and in this case, it's helping science. So I think we should also turn to the universities, and we as academies can do that and say, hey, we might do a better job as universities of including these kinds of, again, that awful word valorization, but these kinds of activities in the way we evaluate the progress and the quality of our scientific staff.
Yes, I think, to be fair to Deloitte, we didn't give them very much time, but a lot of the, also when they have a contract, they've won the contract on the basis that they can do anything, so that's why we can give them a contract quickly. So we don't have to write a call for tender for the particular task that they're given. But it took them some time to understand the problem. That was the difficulty. And in the end, we spent most of the time telling them what the problem was, rather than... And then the reports often explain why it's important, but without giving you the answer as to what to do. But I think there is an opportunity for the scientists to organize themselves to be able to support the policy process. And people do want to help society. It is... scientists like to feel that their work is useful, so it's a bit of a bureaucratic organizational problem, and maybe Johannes can think of some way of fixing it.
Okay, we have Johannes, France, and there was another question. Okay, we'll take those 3 questions, and I'm afraid we have to move over to the next panel.
Thank you very much. I actually don't ask a question. I would just like to say to Ole and Günther that I think what you raised is very important, and I am absolutely interested to share my thoughts, and even though they are not maybe certainly fully developed with you on this, because I think it is an important issue that you raised there. So I am supportive of thinking that through, of how one can advance in that area of rapid advice, and also as regards the award question.
My question is with regard to the report and the trust issue. ALLEA said trust is built on past performance. But if we take agriculture as an example, is the past performance cheap food for many people, or intensive farming and factory farms? And that links into the report on the mariculture. Did you look at the issues with regard to the pollution, with regard to keeping nature, and those issues that are beyond the use of the oceans as productivity source?
That is, we didn't go into detail, but that is how that's where this idea of more food from the oceans comes from. And if you take agriculture as you describe it yourself, think of how much water, think of the pesticides, think of how much land space goes into the production of different kinds of food. And if you take those numbers and compare them with the relative, the more sustainable way in which food from the oceans can be harvested, either by capture or most strongly by culture, that's exactly the point we made. We have to start thinking about mariculture, but it doesn't. Most people think food is agriculture, and one of the points, and that's a point that reverberated very well, and it's not rocket science, but it's, hey, don't forget mariculture. The word mariculture, I don't even know if it it was aquaculture, and that's the sweet water, and mariculture, I'm not sure where the term came from, but believe me, it has gained prominence. Possibly strengthened through this food from the ocean, the report and the scientific opinion.
Yeah, one of the most important points made in the evidence review report of food from the oceans is the question about the different trophic levels. And at the moment, if you're just taking fish, you're actually working on a very high trophic level, because fish feeds on lower creatures and so on and so on. And it's actually, in terms of efficiency, relatively low. And actually the efficiency of fish is actually less than that of agricultural products, which feed directly on plant materials. So the logic of the report is that if you go down the trophic levels, you're actually increasing efficiency. On the other hand, of course, the point has always been made that then you're also taking away the basis for the higher trophic levels. And this is this balancing act that comes out of this report, which I think is extremely important. So there are two elements to that. There's the consequence of it in terms of science advice, but there's also, I think, a very important educational part of this, because this is not something that most people actually think about. So by explaining this to more and more people, and this is where the outreach, I think, is important, we also make sure that the consumers actually understand this point about efficiency, which also, of course, again, has all sorts of implications for the future. So there is both a direct science advice, but there's also, in a sense, the broader issue of bringing out a very, very basic biological point to a larger audience.
Sorry to intervene, Pearl. I share the view that scientists have to work without money for the common goods, no doubt. But in the rapid mechanism we are talking about 3 months, which means that the experts we are asking have to rearrange travel plans, they have to find someone to do lab work, they have to find someone to do the lecturing, a lot of things, and they sit together for weeks and not for hours as they do currently. So we need a new organization, and only for those I am campaigning, because it's a turn in the life. We need to be competitive with the Deloittes, and we must be over-competitive concerning in time, over-competitive when it comes to quality, and we could do that, but we need to think carefully what we do, and if we make the differentiation, then it could probably be a step forward.
Point well taken.
I would still say that there is a competition, so I do not question that naturally. I myself have spent a lot of work working for academies without any remuneration whatsoever. However, we must be aware that there is a competition. So people are asked to do one task which is remunerated, they are asked another task that is not remunerated, and obviously in some cases that will influence their decision. So it's a competitive market. There is a shortage of expertise in many areas. We already know in the academic world we have enormous problems with reviewing of papers for scientific journals now. And I am involved myself as an editor. Typically now we have to ask at least 10 or 15 reviews in order to get 2 or 3 people to review an article. Again, that is usually not remunerated. So there are some real tensions as more and more advice is given. And so I'm very glad to hear that Johannes Klumpers is willing to look into this, because, as I say, at the end of the day, idealism is there, but idealism can sometimes be very significantly tempered by other competitive approaches.
Thanks very much. I'm pleased that halfway through our event we have already a sort of a concrete idea of what can be done. I would now thank my panelists for your insights, ideas, exchanges, talks, and invite my next panel to join me here on the stage. So this would be Günter Stock, Evangelia Anzani, Andy Hart, and Johannes Klumpers. I don't know. I can sit on this one, yes. Okay. Welcome. We will now talk about another very, very practical example of science advice and policy, namely another case study, authorization processes of plant protection products in Europe. We will proceed just as before. Each of the speakers has 5 to 7 minutes, and will then engage in a discussion with you, the audience. I would like to start with you, Evangelia, if I may. Just have to find my cards here. So Professor Evangelia Anzani is a pediatrician and epidemiologist. She is head of the Department of Hygiene and Epidemiology, the School of Medicine at the University of Ioannina in Greece. And she is also the chair of the SAPEA working group on pesticide toxicity assessment. Evangelia's work mainly deals with evidence assessment, with environmental epidemiology, the genetic epidemiology of complex diseases, and with motivating behavior change. And Evangelia will be talking to us about incorporating evidence into scientific policy advice.
Dear members of the public, dear distinguished hosts and guests, dear colleagues, it is with great joy and honor to stand with you today before you. And for this opportunity, I would like to convey to ALLEA my sincere gratitude, that and of my colleagues from the working group, from the SAPEA working group for the Plant Protection Products Evidence Report. In the next minutes, I will share with you my thoughts as they were formulated during the last several months, where we strived to provide a robust scientific background for a very important fundamental policy question. More importantly, I would like to share with you a vision where the values and preferences of the public, of the European citizens, will be aligned with and best served by scientists and innovators, but most of all, policymakers and legislators. An integral part of this vision is a scheme like the chief scientific advisors and their excellent team, and a synergy like SAPEA. During the past months, I have been privileged to work closely with both these entities, and I have only praise to express for their extraordinary effort to transform vision into reality. So in my first slide, there's a blurry figure that is included in the evidence review report for plant protection products, for PPPs. I will be referring to them for the sake of time and convenience. So this will soon be delivered to the scientific community, and of course this pertains directly to a specific policy question and legislation question as well, which is whether a plant protection product should be approved for use, and what use might that be. And this figure depicts our target process for us, the working group, the SAPEA working group for the specific evidence report. Of course, there is no way that you can make sense of any of the information that is provided. I only want you to reflect upon the complexity of the process and the interdependence of the various attributes that constitute the task at hand. So, in brief, we had to deal with 5 milestones incorporated and integrated into the approval process, into the regulatory process for plant protection products. That would be data accumulation, data collection, data evaluation, integrated of this data into a well-defined, validated endpoint system that should be integrated into a functional IT framework for the European Commission, and finally, provision of risk characterization outputs. As a working group, we were specifically asked to provide the scientific current state of the art in human health risk assessment for PPPs and all the attributes that pertain to that specific question. Addressing such a challenge requires a systematic, well-structured, comprehensive, iterative approach that would also be fit for purpose. And why? Because first of all, we need to formulate and refine the research question or the question under study. Every question is unique, and moreover, underneath every question lies a very complex system of conflicts of interest which can operate in different directions for that research question or policy question or legislation question. And conflicts of interest aside, every question can also have other peculiarities. For example, the PPP-related question was notoriously difficult to ask because the scientific field was rich in information and mature policy-wise. Moreover, the eyes of the public were upon the specific question due to the recent media coverage on the glyphosate decisions, regulatory decisions, and scientific decisions. So while formulating our strategy, it was evident that we could not limit ourselves only to the content of the regulatory process. We had also had to focus on the timing of the process as it is formulated, as new evidence comes in, and again on the process itself. So the various gears that would comprise the whole regulatory process are well placed, and if yes, are they well fed by the evidence? Moving on to the evidence itself, it is very important to understand that for this specific scientific field, we were swimming in a sea of data. So we had to pose to address this sea of data in a structured way and we have to tier the various assessment steps during and while we're reaching a final report or a final decision. So, first of all, we need to decide upon what constitutes the evidence, real evidence, meaning evidence that is related to the question itself. We had to understand whether we have the appropriate methodology to address the data and whether we have the capacity as a scientific community to address the data. If the answer to both these questions is yes, then we can proceed to the next step, which is when is adequate evidence available to inform decisions? And here, you know already from your fields that there are phenomena such as the winner's curse, where we know that preliminary findings, although very important in exploratory schemes for further research, often overestimate the effect under study. So we have to wait. We have, in a way, to model and project the available evidence and then be able to say that at this point we are in the position to proceed with evidence assessment. So time is an important aspect here, and good data, good quality data, is another really important aspect in the second step of assessing the evidence. And finally, and more importantly, how can credible evidence can be ensured? So this is a term of validity. This is a matter of bias operating in the field. By definition, we know that bias will be present. We cannot eliminate it, but we can control for it. And more importantly, we can describe it. And if we're lucky, we can adjust for it. But it is quite important to open the debate and discuss on the various sources of bias that could be prevalent in the field. There is no perfect way to do research. There is no perfect way to report on scientific findings. So this is what actually became our major task and target during these past months, and we have tried to address all these aspects through our evidence review report, which was also complemented by a number of options where we would propose scientific proposals, in a way, some scientific options for the high-level group, or as we now know them, the scientific advisors, the chief scientific advisors group, to take into account when formulating the opinion. I will not go into more detail because the time is limited today, but I would be very willing to address questions and entertain concerns during the discussion. But I would like to now close my address to you. And I would like to stress that I am very well aware that most of you, including myself, fully acknowledge and comprehend that perils associated with inappropriately incorporated science into policy are there. Historical examples of failure are, of course, there. However, as Professor Peterson mentioned before, and using medicine and health as an example, I urge you to recall all the numerous, significant, pivotal policy changes that have been implemented and that change the shape and the health of our society for much better. All these breakthroughs have leaned upon science, and this intense sense of duty, of public service, and of the full comprehension of what's at stake is the only reason why we will be able to find a way through and assure a successful outcome. Finally, in this challenging and fascinating endeavor of utmost importance, as we all understand, we are not alone. The whole spectrum of the stakeholders is there by our side, and their presence is our strength, because today we are in the unique position to be able to implement the principles of transparency, inclusion, and participatory balance in our approaches. So always have in mind that we are at the very beginning. Thank you.
Thanks very much, Evangelia, and for those closing words, which make us think, and I think are extremely helpful. Let me try to just come back to some of the things that you've said. You started by saying that one has to be aware of the fact that each question is complex, and this is not a trivial thing. So one has to take time to understand the question and the issues that are underlying and at stake. One also then has to think about what kind of evidence is needed and what kind of data is needed to address these questions, and that the issue of good quality data is also one that doesn't have to be underestimated. You spoke about the importance of timing in several respects, and you reminded us of the fact that we have to be aware of biases, also biases in many different contexts, and I think this is a very useful reminder in the context of our discussion. And you again mentioned the importance of a multidisciplinarity approach when forming a group of assessors for evidence and when thinking about the questions and issues at hand. And yes, you also said that framing the issue, the question that has to be studied, also needs to be informed by several perspectives, and this is something that you came back to at the very end. I would like to hand over to Professor Stock. Yes, that early. You want your input now. But, well, this is the surprise element today, and I will make you wait another minute, Professor Stock, just to introduce you very briefly. So, Professor Stock is the outgoing ALLEA president. He worked as ALLEA president since 2012. He was also chair of SAPEA until late 2017 and is now SAPEA board member. Professor Stock is a physiologist by training. He has held many positions in academia and industry. Between 2006 and 2015, he was the president of the Berlin-Brandenburg Academy of Sciences in Germany, and he is currently the chair of the executive board of the Einstein Foundation and also member of the Charité Supervisory Board in Berlin. Professor Stock, we'll listen to you.
Thank you. SAPEA is now working in real operation since approximately 1.5 years, and I would like to share a few experiences out of this time. And fortunately, I can echo some of the statements which have been made before, but I would like to add a certain amount of own ideas on this topic. The first and utmost experience, again in this position, was to really understand and honestly, and when I say honestly, it does not mean tactically and it does not mean opportunistic, and honestly ask yourself what we as scientists can really, and academies can really contribute to the questions in stake. I think this is a very, very important point and it should not be underestimated. And I would like to make the case in the pesticide case. In the pesticide, the question was an overall question. We heard a little bit of that. But there were parts in it where we definitely as scientists could not contribute. For example, why do different countries, based on the same scientific basis, nevertheless decide differently? So we had to carefully carve out what can scientists honestly with the knowledge today, what can they answer and not. Of course, we have some scientific, sociological data on risk awareness and things like that, and we did a workshop on this question. But this is more general, and it is not at the level of micro data which would be needed in order to answer those questions. So this is the point one. And we do have to make it very clear, and we must be very conscious when we write our reports what is fact, what is educated guess, and what is just guess. I think this is a very complicated and very honest endeavor when we want to be truthful. In any case, we will at almost each step come to the question of uncertainty. How do we go about this? And a good working group will always address this question. So my trust in those working groups that they really address this topic has grown over the years. The second point is we, in the academies, 100 academies have to identify excellent experts. Again, I would argue that our academies have to dig deeper sometimes to find the real experts and not in an opportunistic way just nominate one because it is likely that this guy would like to be part of it. It is a very complicated effort and very honest. We need expertise. We need, and this is something where we have to become better, the geographic distribution can be and should be improved. Gender is an issue all in our committees. And when we talk about expertise, we must be fair and really ask the obvious expertise, but also the non-obvious expertise. And in all fairness, I must say, in many cases, we coming from natural sciences, I'm a medic, we sometimes forget social scientists and the humanities as being a needed expertise. I think we can improve in this field as well. And then the next topic is to convince the experts to really go to the work and take it serious. And I must apologize, sometimes experts are nominated by academies and the feedback why the expert has not been chosen is not yet perfect, and I really have to excuse that we are not yet good at this, but we will definitely improve because there are many reasons not to take this or that expert. The third point is we have to help with the elicitation workshop where experts are asked towards the topic which is at stake. And again, here we have an eminent role as academies to bring in experts and to bring in and take care that the real questions are being asked and probably even answered. And after that, it comes to a point which is still not good enough. And we as scientists have a little bit of lack of understanding. When the expert report is published, it is of utmost importance that we go out in our academies and tell the people what was the process, the question, what was the process, and what was the outcome. We can create very lively academic work if we take those data which are accomplished by SAPEA and talk to the people, because in the end, you made the point earlier, we are not advising the politicians of today only. We are advising also the politicians of tomorrow, and we are advising and helping for judgment our fellow citizens. And therefore, we as academies, we have the opportunity and the responsibility to get those data discussed with the people, and therefore this public interaction, it is not teaching, it is public interaction, is of utmost importance. And what we learned in the first year, it really works. It really works, and there is a high preparedness. Please, all academies, step in and do that. Now, I would like to have a personal remark after many years of advising. It is a hell of a decision, and it takes a lot of wisdom to decide when do you give options, when do you give a concrete advice, and when do you feel that you have to campaign for your scientific opinion. Stem cells, for example, in my country, is just an example of this kind. And this leads directly to the question, how do these three patterns, what we do in our advice business, how do they reflect on trustworthiness? And we do have a trustworthiness of today, but we have a trustworthiness also of tomorrow. And I would like to see that we take a lot of thinking and wisdom in doing these things. My last point is derived from the last discussion we had here, and I may say that as an outgoing person from the SAPEA work, of course I wish them success, but what I really wish is that we can go beyond the 5 years and that we get enough support to really go on, because 5 years in this process of advising is almost a beginning, and we have to consolidate, and I think we have learned and we have earned the respect over the last years that we should go on. Thank you very much.
Thanks very much, Professor Stock. So this was a direct appeal also to Johannes to think about how to consolidate European science advice, and I think he'll take this back to Brussels. Professor Stock, you spoke about the need to honestly assess what scientists can actually contribute, and this is another not a trivial issue. What can academies contribute? What can they not do? And what can they promise? What can't they promise? You also made the distinction between facts, educated guessing, and guessing. Another distinction worth reflecting on. You said that it's important to make more efforts to identify the really best experts and to be as diverse as possible in order to address the topics at hand, and to also include perspectives of scientists and sciences that are not maybe at the first sight the ones that are most or appear to be most relevant for the topic, and this goes in particular to humanities and social sciences. And you stressed again the need for public interaction, and you said that you were very pleased to see that this actually works with the SAPEA context, so this is very reassuring. Johannes, your name came up several times already, so now is your time to take the floor. Dr. Johannes Klumpers leads the SAM mechanism in the European Commission since it was established in 2015. His unit also supports the European Group on Ethics in Science and New Technologies. He has a background in forestry and wood technology. Johannes joined the DG RTD in 1998 and has worked there on a broad variety of issues. And we're looking forward to hearing your thoughts.
Thank you very much, Julia, for the nice introduction. Good morning to all. I am here as the, indeed, I was introduced as the head of the Scientific Advice Mechanism Unit in the Commission, so I am not one of the chief scientific advisors. And you have just to imagine that I would be female and that I would have blonde hair and not reddish as I have. And imagine Pearl, whom you've seen before. So basically this is what you have to imagine when you hear me talking, because all these science advisors, they among themselves take more responsibility for certain topics than for others. Not responsibility, but they are involved more in certain topics than in others. And when it came to the pesticides, the three members of the group of chief scientific advisors, namely Rolf Heuer, Paul Nurse and Janusz Bojnicki, who were the three that were quite heavily involved, were the ones involved from the beginning in the evidence gathering phases and everything. None of them was available to come here today, unfortunately. So I am actually basically replacing one of them here. And another important aspect is that the opinion on the scientific opinion on the plant protection products, the authorization processes of plant protection products, is not out yet. Will be out in a couple of days, but it's not out yet. So we cannot really give you the recommendations that will be in there. So I will, on the other hand, hopefully mention some other aspects that I think were interesting aspects, interesting lessons from that topic. Now, it's called authorization processes of plant protection products. Now, you would think when you start with such a topic, oh, that's easy, it's a piece of cake. Just let's take all those professors around the world who are heading a department called authorization processes of plant protection products. And we didn't find any, actually. So this is the, this title is a typical policy title. It's a typical title that Peter Halligan was mentioning earlier, comes from the demand side. And so there has to be some translation made into where do we go? And Evangelia has described it and Günther has described it. Where do we go to find actually scientific input into that question? And so that is definitely part of the problem of this topic, and I'll go into this a little bit more. And another one is the discussions. Evangelia was mentioning it. I mean, it is almost daily in newspapers, either about glyphosate, either about neonicotinoids, either about 75% insects have gone since 20 years ago or something like that. So it's a topic that is of high interest to the citizens. Otherwise, all those journalists wouldn't write about it. Risk assessment, which is one of the underlying mechanisms when it comes to the authorization of plant protection products, is also not a single scientific discipline where you can go to. Risk assessment in itself relies again on many disciplines, like epidemiology, for example, which was represented, environmental sciences, biology, and plenty of disciplines again. And when you are then entering into a question like authorization processes, you are maybe providing advice at the end that even goes into what people believe, oh, this is actually not science advice. What you're doing here is actually politics. And so with that topic, you are entering into a situation where you are at a very fine borderline between, and here comes back, Peter Halligan was mentioning it, brokerage. So we want, I think like most or every decent scientific advisor wants to be having that role, namely brokering, namely helping the policymakers solving their problems. And when you do so, you are leaving that realm of comfortable, pure scientist. You are engaging into how laws are drafted. You are engaging into the process of making laws, into the timelines of making laws. You are then noticing that there is maybe not only one regulation that is of impact, that is of interest to pesticides, but there is also the Water Framework Directive. There is also the regulations on maximum residue levels in food. There is the Sustainable Use Directive on pesticides. And all of this makes it complex in terms of reply and in terms of engagement. How do you link the scientific evidence on the one side to the advice that you then give? And how you do that, you may actually go in a way describing your advice that indeed some policymakers might feel this is actually transgression. You are actually entering into my field with what you say here. This is not for you, science advisors, to making these kind of comments. This is for me, policymakers, dealing with it. So this is a problem that we are facing with this. And now, when it comes to how we worked, I would like, first of all, to thank SAPEA and Evangelia and David Coggan, who is not here, and Nina Hoppan, who is sitting also there from the SAPEA team, who have been very instrumental, who have been essential in looking into part of the evidence that we were taking into account then when it comes to the scientific opinion. In this topic, we were not able to, right from the start, to set up a or several working groups that could, from SAPEA, that would deal with all of the aspects that then later on we thought were needed to go in this scientific opinion. So the SAPEA, they have concentrated on health aspects, and they did that very well, and all that work done by SAPEA is used. You will see that later on when it is out. It is used, it is referenced in that opinion. We also were relying on SAPEA for a workshop on risk acceptance, risk perception, is by the people, by the citizens, is a very important aspect, and that work is used as well. And then we have ourselves gone, we had to do that quite quickly, into an environmental expert sounding board to also look into these environmental risk assessment aspects that are also of very high importance with the pesticides. So this is a concrete example of a topic where you are getting into that difficulty when you want to be all-encompassing with your disciplines. You are entering into an interdisciplinary context, and that includes political science, that includes social science. We had that already with the Food from the Oceans, and the colleagues, and Ian is one of them, they were so kind that they didn't feel that there was transgression when it came to the political science aspects in the Food from the Oceans topic, but that risk can happen, and I'm not sure whether the other colleagues dealing with the pesticides will feel the same when that is out. And what lessons or experiences, what has been maybe striking, that is maybe a little bit personal in relation to what I take from this topic, and What becomes very clear also looking at the question of risk acceptance, risk perception, is that when you compare this to the medical area, where there is drugs that are consumed by all of us, some of us on a daily basis, or on a weekly or monthly, or whenever you are sick and you take medication. We all know that in the medical areas there have been drugs that have had very unpleasant side effects. Still, this doesn't lead to a general distrust in society as regards medication or drugs. Most of us are happily following the advice they get by their doctors. Maybe not all, but most of us do. And most of us do not put into question the way how drugs are authorized, all the process that is going into that authorization. But when it comes to pesticides, the story is entirely different. What you read about with pesticides is, oh, it is a danger to environment. It is maybe a danger to health. And then you don't read anything about it, what it brings to you, actually, a pesticide maybe. Oh, that's something for the farmers, it helps them. But it's not anything that helps me as a citizen. Whereas with the drugs, you are aware drugs are dangerous. You are aware that there have been problems maybe in the past, but you are also aware that drugs, overall, they help you in getting along with your disease. And that, everyone knows that. And with the pesticides, it's different. So when you read about it, it's all risk. It's all, you don't really maybe know why actually do those people actually deal with authorizing pesticides. Can't we do without them? And so that the public has a different attitude towards them than when it comes to drugs, I would think. And that also reads again, the question of trust was addressed yesterday, that's my last comment, and today as well. And it is evident that in the area of those researchers, scientists that do work in risk assessment of pesticides, they are not necessarily trusted. And there is a lot of distrust. There are in the European Parliament clearly a high number of parliamentarians, just to give you one example, that do not trust, that even believe there was bribery in place. They question the integrity of the researchers, of the risk assessors that were assessing different pesticides. And not only they do question integrity almost automatically for those that are employed by industry, they are not trusted by them at all, but they also question more and more government scientists from the government bodies that are involved in the authorization processes of plant protection products. So we are here in a field where this trust issue is very important, and I think it is not evident how to deal with gaining that trust, gaining back that trust, because it was discussed, you have to gain trust, it is not there automatically. And I do not have an immediate answer how to do this. What definitely needs to be done is that we do our best to provide excellent science, to provide it in a way that it is helpful to policymakers, and to explain it also to the public the best we can. I think that is necessary for trust building, and it will not be easy in a topic like this one. Thank you very much.
Thank you very much, Johannes. You have given us another set of issues to think about, some of them reflecting what was said earlier, like the role of science advisors as brokers, taking up what Peter said this morning, the importance and the awareness that one will have to leave the comfort zone, and this might also result in tensions, something that is not excluded and that is part of the basket. You spoke about the fact that policy questions like authorization processes are very, very complex, and this needs to be figured in when trying to tackle those issues. You mentioned again the importance of interdisciplinarity in tackling those issues, bringing in different perspectives. And at the very end, you spoke again about trust and distrust, and that while scientists overall are still rather trusted, this trust cannot be taken for granted, and you gave the example of risk assessment, and that we have to think about ways to gain trust, and mainly by explaining, reaching out, engaging with others. So thanks for this. I now hand over to Andy, our last speaker on this panel. Dr. Andy Hart is a visiting professor of risk analysis practice at Newcastle University. He was previously at the UK Food and Environment Research Agency and served for 9 years on the European Food Safety Expert Panel on Pesticides. Andy is interested in approaches to uncertainty, the weight of evidence, and expert judgment and risk assessment, so he's the man for this panel. And the title of this talk is Key Requirements for Scientific Regulatory Assessment. Please, Andrew.
Thank you. So I was not a member of the working group for SAPEA on this topic, but I attended 2 of its workshops. And I think my role here today is to bring from those workshops some topics that were discussed which are of wider relevance to the general themes of the last couple of days, and in particular trust and the science policy interface. A key issue for trust in regulatory science is how sure we are that the regulatory process, the science that's used in the regulatory process, actually achieves the goals, the societal goals that are set down in legislation. In the case of pesticides, this goal is written in the legislation, and it states that the process should ensure that there are not any harmful effects of pesticides on human health or the environment. The risk assessment process that's used, for example, for human health, uses this risk metric. It uses the no adverse effect level in rodents, divides it by a factor of 100 to allow for extrapolation within and between species and other uncertainties, and compares it to a conservative estimate of exposure. If the exposure is lower, the pesticide is approved, at least for that aspect of risk. Otherwise, further investigation or non-approval may follow. Of course, the appropriateness, the trustworthiness of this process as a means of achieving that societal goal, that protection goal, depends upon the relation between these 2 things, between the risk metric on the one hand and what we think the protection goal really means. And to achieve that understanding, we need to do 3 things. We need to, first of all, define what exactly we mean by that protection goal. What do we mean by a harmful effect? What are the list of harmful effects that would be of concern to policymakers, to society? What do we mean by not any? Do we mean literally not any, nobody in the whole of the European population? Or is that achievable? Do we need to specify some acceptable level of risk? And what do we mean by ensure? Do we mean literally 100% certainty that there will be not any harmful effects? Or do we mean some adequate level of certainty, some acceptable risk? This has to be defined before we can calibrate the relationship between that policy objective and the assessment procedures and the risk metric that are used in the regulatory process, which necessarily has to be simple enough for practical routine use. Once we've done that, and I do apologise for the text falling, but the slides are now narrower than they were at the beginning of the morning. But once we've done those first 2 steps of defining and calibrate, we need to assess. For individual pesticides, we don't need to revisit the calibration because it only has to be done once. We need to apply the regulatory process that's been defined, and we need to be alert for any additional uncertainties affecting specific pesticides and assess their extra impact case by case. Methods for these 3 steps have recently been set out in guidance produced by EFSA, the European Food Safety Authority, on uncertainty in scientific assessment. And so there is detailed guidance on how to do these things. Calibration is the key element for gaining trustworthiness, and so I'd like to show a bit more about what that involves. Ideally, what we'd like to do is to quantify precisely the relationship between the risk metric that we're using in the regulatory process and the protection goal as it is defined more precisely, and to see what the relationship is and to compare that to the defined level of acceptable risk, whatever that might be. That, of course, will be a societal risk management policy judgment. But, of course, we won't have perfect epidemiological data to quantify the vertical axis of this graph. We will have more limited data combined with expert knowledge, and that leads to uncertainty. We must take this uncertainty into account, and that's been mentioned a couple of times earlier on in the earlier talks. Once we've quantified our uncertainty about the relationship, we can then identify what would be a critical value for regulation. If, for example, we were looking for 95% certainty that the acceptable risk would not be exceeded, then we need if we wanted a 90% certainty, we would need a 95% confidence interval, and then we could read off from this relationship, we could infer what would be the critical value that would be appropriate to use in the regulatory process to achieve the societal goal. So the details of this procedure would differ from situation to situation. It depends on the nature of the policy objective, on the nature of the risk metric, and on the type of evidence that you have available to quantify, to assess that relationship. But the principles are general, and they apply to any area of regulatory science. They apply, for example, to genetically modified organisms, to food contact materials, to food additives. In all of these areas, you have a protection goal defined in some way in the regulation, often with words very similar to this, and you have a risk assessment process involving a risk metric, which is often quite simple, and the relationship needs to be defined. I think this is also relevant. The same principles would apply in the Food for the Oceans recommendations, where it talks about optimizing the regulatory toolbox so as to ensure that the policy goals are met and that the future biodiversity of the seas is maintained while also increasing food production. So, altogether then, this process is key to these three principles that we've been discussing the last 3 days. Of course, the assessment process over here is science on its own. As Evangelia said, we're swimming in a sea of data. But it's only scientific to use that for the purpose of regulation, for the purpose of achieving this regulatory goal, if we understand that relationship. That's key for it to be scientific. And by calibrating that relationship, we make transparent the justification for using that risk metric, that regulatory approach to achieve that societal objective. And furthermore, by calibrating it, we establish the basis for trustworthiness of the approach. We show people that there is objective reason to believe that if we operate in this way, that the regulatory, the policy objectives, the societal objectives will be achieved with the required, desired level of certainty. Thank you.
Thanks very much, Andy. This was, I think, a proof for a social science perspective and the need for it in this kind of project. And it reminded us of the need for an ambiguous definitions for the goals of the policies of the regulations. And this is something that should take quite a substantial role in the entire process. You also said that assessment procedures have to be calibrated in order to deliver those goals with the required level of uncertainty. I think these were really one of the two main issues of your talk. I wouldn't want to go beyond this because we're a little short of time. So I would want to ask for your questions immediately. So please make up your mind very quickly. I have one question here, one question there. I see another one. So we take those two questions, one after the other. Peter, please.
This question is for Gunter. Towards the end of your talk, you mentioned about the issue of framing advice, maybe aspects, and you offered a taxonomy with regard to that. And the question I have is built upon Johan's presentation of the potential for transgression, and that is moving between science advice and policy making. Your taxonomy was based on options, concrete proposals and advocacy. Are there any ground rules for SAPEA with regard to this?
Thank you very much for that question. I mean, we are, when it comes to this kind of terminology, what I am referring to, and I think most people do, is to this book by Pielke, where he divided those four roles. One was the broker, the other one was the advocate, then there's this pure scientist, and so on. And so far, in our work, in that combined effort of SAPEA and the chief science advisors, we have delivered, we tried to be, in most of the scientific opinion, in what we call scientific opinions, we try to broker. So we try to provide advice in forms of options, most frequently that help addressing the issue and that help providing solutions. What was also done is in another type of document which is called Explanatory Note, and that is actually you could refer to this as a pure science element, whereby the scientists limit themselves to describe a scientific, the scientific state of the art in relation to a question, without making any recommendations. And to me, it was a surprise that that in the European Commission is an enormously useful document. In Pielke's book, the role of pure scientist is considered as being not very useful to the policymaker. In the reality of what I've seen in the Commission, this is not the case, because the big explanatory note we did on the science advisors did, and with also SAPEA experts on the new techniques in agricultural biotechnology, has proven useful. It was even interesting for the legal service, who was going back to it and the way how this was described, and they were using it in a court case, actually, as one of the scientific inputs. And it has helped clarifying certain ideas. It didn't contribute to any policy suggestion in relation to a new regulation or these kind of things, but it has been a useful element, and I would actually, with hindsight now, I would not underestimate the usefulness of a pure science approach as well in certain cases.
What's the answer? I don't know. Yeah, but I think it goes back to the idea of straight into advocacy. I want to understand where the limitations are with regard to, because if one feels that one has a very strong scientific case, would one stop short of advocacy?
Yeah, I can say a sentence about that. I mean, when you look at both the food from the oceans and the pesticide, when you are involving political scientists in your expert groups, which we did in both of the cases, political scientists, they look as political scientists into how political systems work, and they make then suggestions as to in what framework policy should take place and so on. And some of their suggestions and some of their wording are identical to maybe what policymakers do, European Commission or other policymakers. Some of them might, on the other hand, using the same type of wording, but might recommend something totally different. And that is, so when you are involving political scientists and you are getting into these political frameworks, and they come at it from a scientific angle, but it might not be perceived like this by the policymaker. It might actually be perceived by the policymaker as being advocacy, meaning you policymaker, this is what you should do with that regulation, and then as the type of wording that is used by political scientists, the way how they think, the way how they formulate, is very close to the reality of thinking and formulating in a body like the European Commission. Here the risk of being perceived as advocate is much higher than it is when it comes to natural science, where natural science is never translated one-to-one from a natural science result into policy.
I have a very simple question, and it would be great to hear a sentence or two from all the panel members. When you refer to the public, who do you mean?
I think I should answer in the following way, that it depends. We have different sorts of public. What we experience in SAPEA, we have had expert public, experts in this group. We have the classical guests in academies, and I think the creativity of the last year existed in the fact that we tried different formats where we tried to get, with extra events, to get the normal public. Those would normally not come to the academy, where we attracted and tried to convey the message as we could. I think we have to be very differentiated whom we address with what kind of messages, and I think we are in the beginning of our creativity process to make this public interaction better than it used to be. Is that somehow? Okay, thank you.
So I think coming out with a straightforward answer, the public is everyone. Because for topics like that, every member of the community has a vested interest in the decisions that are related to regulatory assessment. So there is a huge activity on stakeholder engagement of different groups of stakeholders. They should be there from all different members and groups. So we could have a general public for pesticides. We should have a member of the public as cohabit people who live near fields, people who consume products that have pesticide residues in them. We need professionals, we need scientists, we need the industry, we need regulators, we need legislators, we need scientists that could be affected by the legislation indirectly. So a stakeholder matrix is something that is very important at the very beginning of these projects and at the very end of these projects.
I was also thinking of the public at large, of everyone, meaning that can be the reader of The Guardian as well as the reader of The Sun, or the user of Facebook or the user of Twitter, just mentioning some means of getting to them. And it's a difficulty talking about everyone, I agree.
My inclination would be to interpret the public in as inclusive a way as possible, while also recognizing that there's not just one public, but many different publics. However, I'm not an expert on this issue, and so in the recent work which EFSA, the European Food Safety Authority, has done, developing guidance on how to communicate scientific uncertainty in its assessments. There's a public consultation on the draft guidance at the present time, which you could contribute to, very welcome. In that process, EFSA involved also some social scientists, and we thought with them very carefully about how the range of publics and audiences influenced what EFSA would communicate about scientific uncertainty, and through which of the media and formats that it was communicating, how that would differ between them. And how to maintain a coherence between it so that you don't end up sending contradictory messages.
I don't want to be critical. Of course, we want to reach everybody, but it is a mess and a hell of work to really do it, because you need different approaches, and we need more creativity, and in the end, we need more money for that. Thank you.
We have one last question.
This is not a question, it's just a comment coming from me. This is a reactivity, because this is in front of Johannes and Pearl about, for example, microplastics, because after the Food from Ocean, it was clear that microplastic is a problem in Europe, in every part of the world, and it was raised by Sir Sam at the end of March, and we discussed that during the HLG meeting and the SAPEA, and we agreed that we have 3 steps to work on. So microplastic now is on the way. It's a very hot topic, so the reactivity is very good, coming from the SAM, coming from SAPEA, coming from HLG. I'm sorry, Pearl, because this is an old term from HLG. So the reactivity is very good for the public, for ourselves. So this is a very good point for this new mechanism.
Good. Thanks very much. Thanks to my panel. Big applause. Okay. We are nearing the end of our symposium today and would now like to spend just a couple of minutes on reflections. And I will slightly change the format that we had foreseen, so I will not ask my 4 panelists to join me here, but I'd rather ask you to come one after the other in front of the stage. I'll give you a microphone, and the idea is now that we are asking some of our academies to share their thoughts about today's meeting with us, their reflections, the things that stuck with you, that impressed you, the things that intrigued you, that worried you. So if I can call you one after the other to come here and share your thoughts with the audience, and then I'd like to hear also the thoughts of all the others, the ones. So what will stay with you after you will have left the Bulgarian Academy of Sciences today. So I would say we start with Professor Ulrike Thielmann. She is Vice President of the Royal Society. Ulrike, I'll give you my mic. If you can turn it down. I don't want you to be with your back to the audience.
Okay, thank you very much for inviting me to make some comments. There was so much today to take in, and also the topics went in different directions, and I'm, I think, in danger to add to that. So, but just a few things. I mean, one question we didn't actually hear is what is actually science advice? Of course, it was interpreted quite clearly, I think, science advice to governments, to policy makers. I think, of course, from that point of view, we have also heard the discussion, how far do you get? How far do you go? I thought the name of just calling it an evidence review report is a very interesting one. There was no advice there in this title. But I think advice can also go beyond that. Advice can also be advised by scientists, and that might be in our own purpose, for our own self-serving to some extent. I mean, for example, the Royal Society was asked or prompted to make a statement about Brexit. And of course, we know what the scientific community wants, and we clearly want to express that. And I think that is science advice as well, that we need to advise governments what we think is good for science. But then finally, I think just to think about science advice for politicians and for policy making is too narrow, because I think science advice needs to be broader for the society. Again, just quoting one example, and actually that came up as well as just on the panel session. Science and law is very closely connected. And so at the Royal Society we have a sequence of science and law conversations which seems to be very popular and has now been taken up by also the American National Academy. So finally, we are here a congregation of academies. So really what is the job of the academies to go into this? And I think one thing, again, maybe from my previous comments, is we need to keep the channel of conversation open. We need to be aware. We need to build networks. We need to think ahead, right? Because sometimes it's actually the scientists who know what sort of issues might come up, say, for example, in data science. You know, when there's a breakthrough that it can be game-changing, then these issues can actually be formulated by us. And I think also we need to wonder about what is the infrastructure really for science advice. And I think it depends from country to country, also international is different. But I think we need to build this infrastructure, and I think paying possibly for advice is part of that. So I guess to summarize this point is, I think we need a whole bandwidth of science advice, and we need to maintain that. And that's a big job, I think. Thank you.
Thank you very much, Ulrike. Now I ask Professor Elżbieta Jakowiak to come here to share her thoughts on today. So she's the Vice President of the Polish Academy of Sciences.
Good afternoon, everyone. I am very happy that I can say a few words about SAPEA, and I am very happy that this small baby, because it is really very near-born baby, which is already so big success. And I am also very happy to say that there is one Polish, Janusz Bujnicki, who is playing a really important role as a molecular biologist. He was very useful for all this recent work. So, and I am sure that it is just the only selected expert, because it was mentioned that selected only very well top scientists should be selected as expert, and I think it is a good example. Also, what I was remarked that during all these final sessions, there are a lot of speakers were speaking about interdisciplinarity. It is, and also what was very nicely mentioned by one person that problems are interdisciplinary, and it was going very well with food ocean. How much this problem is open to many different type of scientists, to very different disciplines. And as you told also, it should not be silos between food, ocean, and agriculture. Everything is connected. We should think about everything. It was mentioned that this food ocean report was done so quickly, so efficient, and so on. I am afraid that maybe it was done so quickly because the subject is a little bit long term. Also was mentioned that long term it was not for now, it is for next generation. Yes, if I understand. And it was done also that we need to grow this food a little bit depth. I think you are mentioning about that. So it will be another problems. So maybe it was so quick because it was not touching us so directly. Not now, just it will be somewhere, so we can make a decision very quickly. How to take this food, where to grow it, just in ocean or in Baltic, or this is story can be different completely. And of course, this interdisciplinary is very important. And long term, what you mentioned, that we must think a little bit in the future, not as a politician which only want to have position in the next election, which is just case in our country, I suppose. And what I am thinking here, we are academicians, we are really top scientists and top politicians taken from European Union, but maybe there is not normal politician. They maybe should learn, listen a little bit us. I think we are a little bit disconnected. Okay, it is after some messages given maybe to them, but some indirect. I don't know if it will be not good case to invite them or to give them direct. A lot of interesting messages were given that, but I don't know if it is going to politicians from the countries. It is normal politicians, not necessarily to European Union. How to convince them? Because they are in their own world a little bit, and not always scientists are convincing them about importance of some problems or some issues. Okay, so, and I like very much what was told. It is one science only, one common science, and we should fight for this to make it better and better. Okay, thank you very much.
So, Professor Peter Kennedy. Professor Kennedy is president of the Royal Irish Academy.
Okay, Ireland, we're a little country, but we get engaged in science advice, and we take very seriously our interaction with European bodies, especially the ESEC and ALLEA. So the opportunity to be involved in SAPEA was extremely important for us. The Food for the Oceans project, we had two people working on the team. One a standard scientist and one very much from economic sciences. I saw the report come back, the SAPEA report, which is the scientific evidence, and then we've the Food from the Oceans, what used to be called the high-level group, but it seems to have disappeared. It's now called the Group of Chief Scientific Advisors. So, okay. There's constant change in Brussels. Anyway, when that came back, we had a briefing at home. As we do, we have a breakfast briefing. We brought the material back to Ireland, shared it with policymakers at home, shared it with others at home. And actually, going to it, I learned so much more about it wasn't just the science. And when we talked about the food from the oceans, there was that question of you take more food, well then maybe you've fish farms or farms that are impinging on tourist attractions or other events. And so it's very, very interesting. Then there was a whole discussion about the economics and what's happening at the moment and the implications for Ireland in terms of Brexit. Where were we actually collecting some of the food from the oceans? And so fascinating. And I think the multidisciplinary aspect of it was absolutely important. So for a small academy, I think this SAPEA is fantastic. It allows us to bring things back locally. It allows us to contribute to these wider policies. And I think the interdisciplinarity of it is fantastic for us. So that's my comment.
Okay, Professor Somere from the Estonian Academy of Sciences.
So it's now only me between you and lunch. And to start with, I want to say that there are some differences between internationally renowned experts and mathematicians. I'm a mathematician by education. Differently from experts, mathematicians give you absolutely correct and absolutely useless answer. But they both appear uninvited, and they both don't care what is behind the numbers. There was a lot of speaking today about trust and building of trust. From a mathematical point of view, building of trust is extremely asymmetric. So you build that in years, sometimes in generations, like Ole Peterson was telling, but if you lose that in minutes. And in terms of science advice, the major reason for losing trust in eyes of public, in eyes of policymakers, is if you are arrogant. In Estonia, we are building a science advice system. We are bringing together scientists, media people, policymakers, government officers, but to strictly limit access of Academy members to those meetings. It's people who do the advice, told Günther Stock. So I'm not trying to be patronizing with respect to statistically saying older generation, but life is changing in a pace which many, especially scientists, cannot follow. And if we want to make science advice operational, then, very simply speaking, we have to locate those people whom we can call on Saturday night and who will take the job. This means sort of a circular effect. In very old times, Newton's science, being a scientist, was a hobby of rich people. Then with the nuclear bomb, etc., came science as lifestyle. Now it has been turned into diagnosis, and it will be addiction very soon. But back to the science advisory mechanism and this sort of advice which is being built now. I think that there are three paradigmatic changes in how SAM and SAPEA are building advice. Science advice to your commission is exactly as old as commission itself. But there have been never three kinds of separation. Separation of advice from simply willingness to be important. So that's in more scientific words, we're now trying to avoid eminence-based advice. Second, which is well understood, SAM is trying to separate advice from lobbying. There are very powerful lobbying groups who attack the Commission all the time with piles of papers, and basically every lobbyist comes with reports in hands which exactly tells things what the lobbyist is wishing to say. And this is intrinsic also for evident bodies like European Marine Board, to where I belong, and European Polar Board. There is always a lobby inside. SAM is trying to be without lobby. If we can keep this paradigmatic separation, there are good chances to be a winner. And third thing, which is not so clear, it's separation of voice of science from the voice of cash. It is a very subtle thing, but it's extremely important. It doesn't mean that scientists shouldn't be paid, but their voice should be separated from the voice of cash. There are other paradigmatic changes which science advisory mechanism is trying to bridge, actually. If you look how science was functioning in old science and how it's functioning today in science for industry, there was a very strong chain which was localized both in space and time. So there was somewhere was sitting a scientist, in next room there was inventor, next corridor was engineer, and next street was factory producing something. It's still there in industry, and scientists was paid and is paid industry from the profit earned from the goods which inventor and engineer made. In public science, there is now a very clear separation. There are many excellent scientists who are doing science and putting that somewhere which could be called either sea of knowledge, was told today by Evangelia, I believe, say it's a multiverse of global knowledge. And there is another group of people much larger, inventors, engineers, entrepreneurs, they fish ideas from that pool. So the production and use of knowledge has completely changed. So the successful catches by engineers and entrepreneurs are converted into some products which are sold, and then public tax money is generated from which science is funded. This sort of separation, even if it's quite inconvenient, we need to bridge that. And this sort of separation has actually very strong ramifications in many other parts of society. For example, in a family, the knowledge which we try to tell to our children or grandchildren, this doesn't function anymore. The children have access to this generic pool of knowledge, and we can't pre-select what they take from there. And if we try to educate people starting from primary school, like José was telling yesterday, it's far too late. And those things have come here to stay. We can't avoid them, we can ignore them, but they will work, they will change the society. And if you want to have a simple test of resilience, of trust between you and politicians, tell them what the progress in IT sciences will do very soon. I mean, the societal effects of inventions like timestamping and blockchain, very soon they make lying about the past impossible. And moreover, there is no need for trusted body like a minister, ministry, bank, or notarius. It's all done in your computer. Tell that to politicians and measure the reaction time in milliseconds. Thank you.
Thanks very much to our four speakers for those broad reflections. I think you've reminded us of some of the issues that we discussed today, but also looking way beyond what we've discussed today. So now it's just me between you and lunch, which I'll shamelessly exploit. I'd like to thank very much all the speakers for sharing their thoughts with us, for sticking to the time. I'd like to thank all of you for being here at an early hour, staying with us. I'd like to thank the hosts for their very warm welcome. We have, I think, achieved a lot today. We have covered a lot of ground. We went through a number of different topics. Just want to mention very, very few of them. So we agree more or less that scientists who want to provide science advice or policy making are knowledge brokers, that this comes with some strings attached. that it's very important to think about the timing and the urgency of certain issues. Training capacity building is very crucial. We spoke many times about interdisciplinarity and transdisciplinarity and how this can be done and how this actually already works in practice. We spoke about the need to reach out to the public, to engage the public, what public actually means, and how also this can work, and we've seen that in the SAPEA context it does work. We spoke about how to identify the real topics and how to frame the real questions and what needs to be done in order to do this in a meaningful way. We spoke about the importance of partnerships. We mentioned trust several times, trustworthiness, how can it be gained, etc. We spoke about the policy circle versus the science circle and how they can be brought together, or what the issues are that one needs to be aware of. We also alerted us to the fact that it's very important to be aware of the fact that there are also other sources of advice to policy and not only science, and that this needs to be taken into consideration. We spoke about reliability, authority, transparency. We spoke about reward systems in several perspectives, be it monetary or visibility recognition, that some work needs to be put into those. We spoke about impact and how impact can be traced, how impact can be achieved, how science advice can be effective. We spoke about communication and how communication needs to be done in terms of also uncertainty, in terms of risk, balancing of risks. We were reminded of the need to honestly assess what scientists, academies can do, cannot do. That we also have to make more efforts to include the best knowledge available in all respects. That the timing is important, and that issues are complex and need to be considered as being complex and not easy to solve. And I think this is something that is true for this whole aspect of science advice. As many people said, we are at the very beginning of this process, but we are definitely moving forward. We're gaining a lot of experience. This meeting today, I think, was very helpful. I thank you very much again. Now it's time for lunch. I'm not sure whether we will get food from the ocean, but we will for sure get something nice. Another very practical note for those of you who have to head to the airport today. Please be practical, leave not too late, and ideally you use the metro and do not rely on taxis. So with this very practical note, I would like to thank you again. Have a very nice day. Stay in Bulgaria. Enjoy the lunch, and thanks again for being here.
Разбираш, ще имаме.